Hi guys, this video is comparing and finding key features of exponential and logarithmic functions. This is directly related to the Delta Math assignment that you have for today as well. All right, so exponential and logs should look familiar. You did them in Math 3, so this should be mostly a refresher, hopefully. These graphs look similar. They are related to each other. Exponential and logs are inverses of each other. When we're solving exponential and log equations, they cancel each other out when we're trying to get x by itself or y by itself, whatever we're doing. So the main difference and how you can tell the difference between one or the other. All exponential functions have a horizontal asymptote. Logarithmic functions, every single one of them, has a vertical asymptote. So you kind of need to memorize that. You also need to know how to write the equation of these asymptotes. So horizontal asymptotes are always y equals equations. And on the parent function for exponential, the asymptote is at 0, which is the x-axis. So you can see here, I should always have one arrow approaching the asymptote, going flat along that imaginary line. So it doesn't have to be the left arrow, but this is the parent function, so this is the way that it looks. All right, with vertical asymptotes, those equations are x equals numbers. And again, on the parent function, that is x equals 0, which is the y-axis. So you see, again, I have one arrow that should always be going straight, flat up against that asymptote. All right, so the easiest way to tell where the asymptote is going to be is by looking at the equation. A horizontal asymptote is affected by a vertical shift, right, up or down. So that's the plus and minus numbers that are at the end of equations. So if it's an exponential equation and you see a plus at the end, that horizontal asymptote has shifted up. If you see a minus at the end, it has shifted down. The vertical asymptote is affected by a horizontal shift. So that's with the x. So if you see plus, it went left. If you see minus, it went right. Remember, those transformations were something that we learned about in Unit 1, so that should start coming back to us again. All right. Exponential functions. Every single exponential function has a domain that is all real numbers, negative infinity to positive infinity. The range is the one that is limited, and it's limited by the horizontal asymptote. So remember, range is always low to high, right? So for my particular graph, the horizontal asymptote is at the bottom of the graph, and then I have an arrow going up. So for this particular graph, my range would be a parentheses 0, because that's where the asymptote is, and then up forever and ever and ever. All right, this is reversed for a log. For a logarithm, your range is all real numbers because an arrow is going to point down and an arrow is going to point up. So for a logarithm, your range is not limited. However, your domain is. Your domain, I did not leave myself enough room. Your domain is limited by your vertical asymptote. So domain is left to right. So on my picture, that asymptote is all the way to the left. So that's the one that I'm going to write down first. Again, it gets parentheses because a bracket is only for like maximum and minimum points. Asymptotes get parentheses. So that is 0. The furthest to the left that this graph goes is 0. But I do have an arrow that will point to the right forever and ever. So infinity. All right, you also need to be able to find the end behavior, which again, we've done, so it should start coming back to us. Now with exponential, you should always have a left arrow behavior and a right arrow behavior because you actually have an arrow pointing to the left and an arrow that will continue to the right. So one of these is always going to be a number because one of your sides should always be going flat up against that asymptote. So remember with end behavior, let me pick a different color. With end behavior, if your arrow is pointing up, that's infinity. Down is negative infinity. But if it's approaching a horizontal asymptote, we need a number. So for mine, my left arrow is the one on the horizontal asymptote. So remember, the left arrow is always x with the arrow negative infinity. Negative because that's where the x's are negative, is to the left. So my y's, because my left arrow is on the horizontal asymptote, my y's are approaching 0. So again, that horizontal asymptote number coming back. That horizontal asymptote now has come up in the range, and now it's also coming up in the end behavior. All right, my right arrow on the graph is pointing up. So that one is infinity. All right, now logs. Logs do not have both arrows. It's only going to have one. The other arrow is going to be the number that your vertical asymptote is at. So if you can see, look at what my left arrow is doing. My left arrow is not actually continuing to the left. It's not pointing to the left at all. It's actually being blocked by this vertical asymptote. So in this case, my left arrow is not going to say negative infinity because this arrow is not going towards negative infinity. This arrow is getting blocked by the vertical asymptote. So my left arrow is actually going to 0. Now my right arrow is actually going to the right. My right arrow is going to infinity. All right, so my left arrow, remember this part of your end behavior, the part that you're filling in, that's what you're looking at over here, whether it's up, down, or going flat towards a horizontal asymptote. That's what you're filling in. So when I go to fill in these Y's over here, I'm looking for whether it's up, down, or flat. So my left arrow is pointing down. My right arrow is pointing up. All right, so here's an example of one that has been transformed. So we will go over what all the rest of the stuff in the formula means, but for right now, this particular assignment is focused on asymptotes and key features of the graph. So right away, I'm going to notice this -2 that's at the end. I can tell this is exponential, and that -2 at the end, that's telling me where my horizontal asymptote is. So my horizontal asymptote is at y equals -2. Now I just graphed this in Desmos and then drew it on my paper, so that's how I knew what it looked like. All right, domain. Every single exponential, the domain is all real numbers. Range, low to high. The low of my graph is -2. The high of my graph is going up to infinity. All right, I do have a left arrow and a right arrow for exponential. They always have both. So negative to the left, positive to the right. All right, if I look on my graph, here's left, here's right. So my left arrow is pointing up. My right arrow is the one going flat. So my right arrow is approaching -2. It's not pointing up, it's not pointing down, it's pointing flat. All right, here's my log equation. So this is the part that's going to help me figure out where my vertical asymptote is. The shift to the left or the right is with the x in the equation. It's not at the end. Anything at the end is up or down. And it's always opposite. So if that says +3, I know that means left 3. So that means this is the line x equals -3. So it has that vertical asymptote at -3. All right, so domain, left to right. The furthest to the left that my graph is going to go is -3 because it's getting blocked by the asymptote, but the right is forever and ever and ever. Range is always all real numbers because I have an arrow down and an arrow up. So in this case, my left arrow is the one going towards my asymptote. So my left arrow is going to say -3. My right arrow is going to say infinity. If you notice, for these, your left and your right arrow should match the parts of your domain. So my left arrow is pointing down. My right arrow is pointing up. All right, so when you're filling out the left and the right arrows, the left and the right components should match the beginning and the end of your domain. And that's kind of opposite from exponential. Exponential, these are the parts. See how those match your range. All right, so there's going to be one question for you to try in the Edpuzzle that you're watching today. And then again, this goes with your Delta Math assignment. Your Delta Math assignment is not that long.